Good afternoon, sir. Hello.
Hello.
Sir, can you please tell me the what will be the syllabus for exam? What I mean to say is, what will be the weightage of different
Eh,
topics covered so far?
Everything will be covered from the first lecture till end of today, the last second. Okay. Everything will be
Okay,
covered.
sir.
I don't know. Actually, honestly, I have not thought about the exam. That's reason I need 1 week to prepare the question paper because it's not easy to prepare multiple choice questions. Okay. So I have to
Okay, sir.
think through how to prepare, what to prepare. Possibly there will be some question that will be repeated from previous exam, but not many. But I think everything I would like to cover. Of course, I mean the part of the syllabus that is not asked in the last exam, about 70% possibly would come from there. Remaining 30% come from the older ones also. सोचा
Okay,
नहीं
sir.
सिंपल ही होगा क्योंकि बिकॉज इफ आई कैन सॉल्व इट देन आई एम श्योर यू कैन आल्सो सॉल्व इट सो ज़्यादा टफ नहीं होगा largely if you've gone through slides then you should be able to answer almost 70-80%. Remaining 20% I have to give you little tricky questions, which will require you thinking.
Okay, sir.
70% will be something which you should be able to answer. Okay. And
Thank you,
I
sir.
want you guys to tell me the date after 20th or something, because I need time and I'm busy for 2 days doing some other work. So I need 1 week time at least. It's okay, around 20th or something, 21st, whatever. You give me a date. It can be on weekend also. It doesn't matter, right? So, okay. How many people? 22 people have joined in. All right. Okay. Okay, folks. So this is the last lecture of the syllabus. Okay, and we'll not meet after this. That's a Monday class I will not take. And initially, I thought we'll have a concluding lecture, but I guess that's okay. You guys know now enough. Um, so I will not have concluding lecture. So we'll try to finish it. Today's lecture is a little longer. It may take more than 1 hour. So be patient. And if you need break, just let me know. Okay. Now this topic is important because all of us are going to use data center very heavily, okay, or cloud very heavily, right? It's a new computing model altogether, and most likely I think that you know about it, you know possibly as much as this presentation contains, because what I have tried to pick up in this presentation is very generic, very general things, right? So we have not gone into much details. For example, initially I prepared a lecture on how cloud computing you can do computations, like how can you break down your work, what are the traffic patterns inside, and then there's some kind of computation that we do in cloud, uh, for example in Google query. And so I have excluded all that, and today we'll focus largely on the architecture and why, a question of why we need all this, right? That will be answered rather than going into details of data center architecture. If you guys really need any more input onto it, we'll be happy to take some class, maybe sometimes in the next semester if you want. Otherwise, I have also sent you a paper, that's written by California, Berkeley. This is a very good paper, and very well referred, right? It's most of the people who work in data center refer that paper. So it gives you good idea about cloud and data center if you go through that paper called WSC. It's a warehouse scale computing. Okay, all right. So we'll start now. So we'll cover these topics. Computer evolution towards cloud. Why data center and cloud? Data center cloud computing. What is inside a data center? and requirements of data center and cloud, and then few service models for cloud computing. Please feel free to ask me if you have any question in between. Okay, all these things we know. When I started working, of course, in 80s, computer still used to look like this. The mainframe computer I worked on for the first time was bigger than, it acquired almost like whole building, and we used to call this computer center. Um, Even when I joined job in IT Madras as a teacher, even then there was a computer concept of computer center, and that's a huge building occupied one mainframe. Okay, or big computer. So we can see that this is it used to be very big. This thing was a CPU, that's shown here, and these are all IO devices, right? So it started from there, because the first one used actually vacuum tubes. I'm not sure you have heard of vacuum tubes, but there used to be diode, triode, and so on. My In my home, my father assembled one radio. Now we don't have concept of radio, right? I mean, or you would have seen transistor radio, right? But it was a radio that was actually made of all vacuum tubes. It was very interesting to see how electronics has evolved. And then 70s we had this mini computer, right? We had HP or Digital was a company, very famous company, had this and this was made largely for labs and universities, and the CX and Unix evolved around that time. And then we had PC era, right? I mean, um, and these were very expensive, um, around, even around 90s it was quite expensive. Okay. I mean, it's like this, my few months salary, at least 6 months salary went into buying one PC at that time in early 90s. And now, of course, late 2000 we have this era of personal mobile devices, like, mobile devices started becoming popular around 2000, I would think 2005 onwards, around 2000 onwards. And then these mobile phones took the shape of a mobile device or mobile computer. That was around 2000, maybe 5 and so on, when Apple came. Then, suddenly mobile phones have changed from mobile phones to mobile device or smart device, where making a voice call was just one application, and other application was applications, right, that you can run. So it was very interesting. And now we are seeing that there is a movement towards cloud computing or warehouse scales computer, which is nothing but, very large computers. We can visualize a data center which consists of thousands of servers as a very large computer. Okay, that's what we call as warehouse scale computer. Okay, so we'll look at these concepts little later. Okay, so now the question is that why do we need data center and cloud? Anyone can tell me? Okay, maybe I don't know who can tell me. Maybe I can see very few people. Okay, I have not asked any questions so far to Sohan. Sohan, you tell me.
So data centers actually, so like for some project which we are doing remotely in the Spanish area, we can use IIT Goa servers for it. So that can be useful. So that can be one application.
Mm-hmm.
So other it can, I think it gives us a sense of mobility. Like we can use cloud storage, like for Google
Mm-hmm.
Drives and all. We can access it from wherever we want. We don't have to carry each and everything with us. Like it gives us a sense of mobility.
Very good. 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 What else? Suppose you have a small, you have servers in IIT Goa campus, right? Which you remotely connect. Okay, can you say it is a cloud or data center in some sense?
So it's not that big, I think. Just but so like
Okay.
Google centers or maybe Zoom, what we can say, Zoom storage centers, like they
Mm-hmm.
are too big. So they'll have to manage for much larger public, we can
Mm-hmm.
say.
Okay.
They'll have to store data of each and every user, whoever is using the product.
Yeah, okay, very good. Excellent. Very good. I like it. Anybody else?
So I think that which Sohan mentioned, our
Mm-hmm.
IIT Goa, it should come in the data center, not in the cloud. I think so.
Okay, all right. Okay, all right. Good, very good. Good attempts. All right. So let's
Mm.
look at it, right? Let's look at the requirements of what data center and cloud. Actually, these terms, what you have said is absolutely right. These terms are used interchangeably, right? So when we say cloud, generally we mean by data center, but data center actually is about infrastructure. Okay, it's infrastructure of servers networked together, very tightly coupled networks, such that we can do distributed computing there. All right. So, and while cloud in general is term we use for something that is very virtual. Okay, it's like you are connecting to a cloud, and then that provides you infinite resources and infinite, computing resources, communication resources, storage resources, and interface is known. Like Google Drive interface is known to you. So when there is a service aspect that's available to you virtually, then generally we use word called cloud. Cloud is related with services. You can envision. So for example, you're starting a company and you want to create your website there, right? This a website is hosted there. Okay, all you need is your HTTP afterwards, right? Or somebody needs only address. That's it. Where it is hosted, how it's hosted, how many servers are required. That's it doesn't matter to anybody or you where exactly the website is hosted, right? As long as it gives you something that you want. So it's like it's available somewhere in virtual world, maybe on cloud, and it's available to me. But that service is in turn is possible because of cloud infrastructure, which is nothing but kind of data center. That's it, right? So we can also have a data center in uh, data center is nothing but collection of servers put together to solve a task. So data center can be anywhere. Okay, and data center types are various, which we'll look at into it. One is organization database data center. Like IT Goa can have its own data center. Okay, where there are hundreds of computers put together, and most organizations do have that data center. Okay, but when we say public data center or kind of cloud, okay, or a public cloud in general, right? So then it is massively built data center that is shareable across number of customers, right? So that's the distinction. The cloud can also be created by an organization for its employees, right? But it is a private cloud. Similarly, private data center. And when we use word cloud in general, if you're not putting private or public, it means that it's a public data center, like Google's data center or Google's cloud. Okay, because we don't know where Gmail servers are, right? We just use Gmail interface to that in a particular form, say HTTPS or something, a link, and then it comes to us, right? So that's the distinction. Let's go into detail, and then you will possibly we can answer these questions all over again. Okay, let's look at different angle altogether, right? So we are seeing that there is a data deluge, right? Uh, there are thousands of or not thousand, maybe billions, not maybe part of the population that we have today is using internet, right? A significant large number, close to half a billion or maybe more. Okay, they are using internet in some way or other, and everything that we use, okay, is recorded. Even this thing that we are doing is recorded. Okay, even if I don't want to record it, there's a possibility that somewhere it's getting recorded. Okay, every transaction that we do, for example, you're doing any purchase on amazon.com is getting recorded. You're sending any email to anybody is getting recorded, right? Whatever Facebook changes you are doing is all getting recorded, and it's all there. Okay, and there's so data that's getting accumulated and people are using enormous amount of data. Is there is a data deluge, right? It's like tsunami of data that's coming. Okay, cell phones, any phone you make, call you make, its data is available somewhere. In fact, government actually saves what conversation you had. Okay, so everything is kind of getting saved, and now this data needs to be, and this data is available generally. For example, your voice data may be available with the government. Okay, your purchase data is all available with Amazon or Flipkart or whatever we are using, right? And then that is needs to be stored and then the manipulated, and it should be retrieved. We should be able to retrieve it, right? And we can see that, for example, in Facebook, in general, there is a saying that 80% of data on Facebook was produced last year. It means that the growth is so much, right? That the data produced in the current year is significantly higher than data produced in all previous years. Okay, and then, for example, the Facebook is building exabyte. Exa is basically 2 raised power 60 byte size data center. It means that that is kind of data volume that should be able to handle. All right, so so because of all this data needs to be processed, kept somewhere, right? And that may also require, not only requires huge storage, but also require computing to do computation. For example, you just search your name in Google, it will result into maybe thousands of internal searches and more than that, right? And all the data about you, is available in some form or other in Google, right? And this reason is able to answer your things very quickly. uh, of course there is an algorithm for that, possibly in some course you will study that, but what I'm trying to say is that because of this data, processing needs are also very high. There is a need for, and it cannot be done on a single computer, right? Whatever computer you can think of, it cannot be done, right? And hence you need huge amount of computing requirement. Okay, so again I have brought in Moore's law here. Data grows faster than Moore's law. Okay, of course there are two applications that are shown here. One is for DNA sequencing. So if you look at DNA sequencing all over the world, that's happening. The data growth is going in this way, and bottommost is Moore's law, or computing is going in the following way, right? And there is a gap. Like in case of memory, we have seen there is a gap. Similarly, data handling, data availability versus computing capability, that's growing. So because of this gap, now this curve always shows for single computer, single processor, right? It means that because of this gap, you cannot solve the problems on a single computer. Single processor or computer is cannot solve all your activities, right, or the problems. And that's the reason we need massively parallel computing. And we have seen in the last class, at least two of them are. SISD is actually for basically single computer, which cannot be used for this kind of applications. So we have SIMD and MIMD. So these are two mechanisms we use in data centers. All right. Okay, and that is one reason, that because of so much of data cannot be stored in individual computers, and even in a largest possible size disk. So we need, for even a small problem, we need thousands of disks or terabytes, or not terabyte, terabyte of or maybe 2 raised power, say 50, 60 size of data storage capacity we need, and that's not possible in single device. So we need to network these devices or network this storage to create a large size storage. Okay, that's only possible when there are not only computers, but these storages are also interconnected, and can create illusion of very large size storage. Okay, and not only this, but also there is applications also growing, right? I mean, suppose, let's look at example of Amazon's website is to be hosted, where a number of transactions happening per second is in surely in millions. Okay, uh, so where can you host this? So look, think of largest possible computer that you can create. Even with multiple cores, it cannot host such a size of an application. Okay, so we need massively parallel systems where I can run this kind of applications. Okay, and these of course demands high computing power. Okay, because there are millions of transactions needs to be handled efficiently, accurately. Okay, and also require high amount of memory, not only storage, secondary memory, but also high amount of cache, high amount of main memory. Okay, thirdly, what I also would require is high availability. Availability is that system should remain available to me. Okay, note that there's a word availability is different from reliability. So there are word called availability and reliability. There's a difference between two, right? What is the difference? Reliability says that my system should not fail. What is the probability of my system's failure? Okay, or what the probability of my system remain in non-faulty state for some time. So after say 1 year, what is the probability that my computer will remain working without any fault uh, for certain period of time? So reliability is always with respect to a time instant. So we can say reliability of my system is say 0.99 or something like that. Okay, availability says that my system can become faulty but immediately become available. Okay, so after say 100 hours, my system is 99.99 times available. It means that there is a possibility of fault happening, but recovery from that is very fast, right? So in general, we cannot say that I can create a system of say 10,000 computers extremely reliable, that none of these computers can fail, or none of the components keep failing, because electronics after all. Okay, and then so we have mechanism to create a system which is highly available. Even if something fails, then we should be able to recover from situation. And so all right, so coming back, so system should be highly available. It means that if I am for Amazon website, even if it's some processor fail, and I'm sure for Amazon every second some processors are failing, but this overall system, this is a massively parallel system, should have capability to recover from these failures. Okay, and of course we need low access time. If you are making a request to Amazon, for example, you want to buy something, and if it takes few minutes for you to show that item, then you may not want to be there, right? Because you don't want to waste 10 minutes to buy a small thing, right? So while there are millions of transactions happening, but your transaction, the access time for that should be very small. Okay, so these are some goals we have taken with respect to example of Amazon. It could be anything. You can, this I just thought about it and then gave this, but you can think of same requirements for any other application on this size of application, this size, large size of application. Cloud email, for example, Gmail, Yahoo, etc. These cannot run. This is humongous size application. Imagine Gmail for millions of users. Okay, and this requires very high all this, right? Computing power, availability, access time, and so on. I mean, when you're checking an email on Gmail, then it responds you want few milliseconds, right? Less than that, actually, less than milliseconds, right? So your whole page should come to you in some milliseconds, not in seconds. Okay? Search is extremely compute intensive and memory intensive operation. On demand video services, we see that Netflix, etc., or even what we are doing now requires huge amount of bandwidth and a huge amount of computing power somewhere or other, and so on. I mean, social networking, of course, all of you must be using Facebook, etc., right? So these kind of applications that we have seen now cannot be run on a single processor. Whatever be size of processor, we cannot do that. So we have to have massively parallel processor. Okay. All right. So that's the motivation. And secondly, there is something called on-demand computing, on-demand services, right? This is a time of on-demand. Everything you want on demand, and you want to pay for it. Say, for example, have you ever thought of why? Okay, and let's take example of very simple that we use, right? You have seen services of Ola and Uber, right? Okay, these are taxi services, right? Why are they becoming popular? Have you thought about the business model for Uber and Ola? Anybody? Okay, who can tell me? I'm sure all of you would have used this, right? Sometime or other. Nadish, tell me. Nadish, you are there? Okay. Nidhish, next person. Nidhish?
Hello, sir.
Ah,
Yeah, so I think they are becoming popular because all the users, I mean, they
mm-hmm.
can. Sorry, sir. Am I audible now?
Yeah. Go ahead. Go ahead.
Yes. So I think they are becoming popular because the users can anytime book their cabs or I mean they do not have to go standing on the road and then call for a cab and
Right.
wait and exhaust the energy there.
That's right. So
On demand.
on demand service available to you. Okay. What is in it for a cab company? Cab. See, look at this way. Okay, all the shared services that we have today, we want to use a car or driver service only for short period of time and want to pay for that, only for that. The other extreme is that I have a car and I have a driver. Okay, in fact, I had a car and a driver, and then I actually calculated that my car is being used only for say 1 hour a day, office close by, and driver is also used for 1 hour a day. Okay, and it is and driver is supposed to work 8 hours a day or 9 hours a day. So I am able to use only 1/8 of his capability. Okay, and for the car is available for me for 24 hours, and I am able to use 1/24th of its value. Okay, while I am paying for 8 hours and 24 hours for car per day. So my utilization actually is less than 1/10, or in case of car, it is less than maybe 1/20th. And if I look at the whole year, considering holidays, etc., my utilization of car is less than 1/30th or 1/40th, and I'm paying 30-40 times for my car. Okay, and what if I need multiple cars? All family members and friends want to go to some place. Then this my model of having one car and driver fails. Instead of that, I can an on-demand service. When I want 10 cars, I can get it, and I need it only for half an hour. I just want to go to movie theater. Okay, it's available to me only for drop to some place. Then why should I have a car and buy a driver? So that on-demand service things is happening anywhere, right? Suppose you hold a conference today in IT Goa, say hackathon, and you need say 100 computing machines for that. You need only for just 4 hours. Okay, see, the solution that I had some many years back was, buy 100 computers. That's it. There was no other solution. Okay, but today I can buy, or I can take it on rent, 100 computers for 4 hours and pay only for 4 hours. Okay, so that is called elastic or on-demand computing. So that is available today, and that's the reason no company wants to have their own data center or own computers. As simple as that. Reason is very simple. Reason is that utilization of these computers in any organization is very little. Okay, actual time somebody is using computing system is not even 4 hours a day or 3 hours a day, and then you need enormous amount of resources to maintain, manage those things, right? You need a multiple IT people uh, and so on, right? You need also something will fail, you have to continuously buy, you need purchase department, maintenance department, all that. The huge amount of money that you need. Instead of that, you can actually get what you want from the cloud or data centers, right? So today's cloud provider can provide thousands of computers to anybody for short period. Today from Amazon, if you need thousands of computer, you can just buy it. Okay, and as a result of that, you don't have to pay for all this. Okay, and this only way to solve this is nothing but you know so instead of having multiple computers to solve it, and we have seen we can't scale up the capacity of a single computer because of the constraint that we have seen, right? Power constraint, heat constraint, and we cannot we can go to some multiple cores, and beyond that nothing. So only solution left out is that we have to have massively parallel systems available on demand. Okay, and now that is good for user, but what is good for the service provider? We'll look at that, right? All right. So we have seen that one machine cannot process or even store all the data. Solution is distribute data over cluster of cheap machines. Okay, when we say cheap machine, the catch here is cheap machine. So data centers don't have full-fledged laptop or desktop, right? They have something that is very bare shell or minimum. Okay, and these are, and once if you buy say a machine, you if you spend say 40,000 rupees to buy a machine, okay, same capability if you buy in mass, say 10,000 machines, okay, and possibly you assemble it yourself or you buy it, then you can buy it for 10,000 rupees. So 1/4 and 1/5 cost you can buy it for, okay. And then you customize it. You not necessarily need then Windows or Microsoft Word or all that, right? You may just need a minimum amount of software, some local OS that you have developed yourself to run over it, okay. So, and because of that, low cost infrastructure in the per unit cost is very, very low. You are able to achieve that kind of cost and you can pass on that benefit. You means that the data center can pass on that benefit to users, okay. And not all users have demand all the time. So assume that there are 50 students in a hostel and they need taxi. Not all 50 will need taxi together, okay. So if even if there are 2 3 taxis hanging around in the campus, they can possibly meet the requirement of everybody. So you may have some peak requirements sometime, while others don't have requirements. So overall, with certain capacity, the data center can easily manage the need for multiple users, and these needs can grow and shrink, okay. It's kind of statistical multiplexing that we see in case of internet. It's similar thing that demands are also going up, shrinking, and hence data center is able to handle requirement for everybody. See, all of us, if we start checking our Gmail, whatever users are there, Gmail together, then Gmail system will crash. It's certain. Servers will crash, right? Now, there is a very clear assumption that all over the world, people will use it at different point in time. Okay, all right. Okay, so cloud computing provides us illusion on infinite resources. Now look at the illusion, same as the memory we have seen, right? We have illusions of very large memory which is very fast. Similarly here, the data center or cloud gives us illusion of very large size computing resources, very infinite computing resources, because as much you want, you can get it, okay. And this is short term on demand resource allocation, and they will, you may need even for 1 hour, you will get say 10,000 machines for 1 hour, okay. And it's usually less expensive than only, of course it is going to be less expensive because if you have to go 4 times in a week to place somewhere outside, having a taxi is much cheaper than owning a car, okay. And that's the reason many people in US have stopped owning a car, right? If you stay in metro, then you don't need at all a car. And if the availability of this cab, or on demand cab service is good, okay, all right. And they can use the best possible technologies inside, right, to give performance. So question is that why cloud computing now? Some Many answers we have already given. So it's, usually 10,000s of these computers are put together in a data center. It's largely driven by growth. There's a more demand, so there more data center will come in, right? And more and more we are demanding now. Okay, we all of us are using Gmail, Facebook, Twitter, or whatever. Okay, and then this point we have already discussed. When we buy in bulk and do anything in bulk, even provisioning, maintaining in bulk, then it is 5 to 7 times cheaper than actually doing individual. So if I want 100 computers for my requirement, okay, instead of that, if I hire 100 computers from say Amazon, then for Amazon, the cost of that will be at least 7 times less. Okay, 6 7 times less. And that's all possible. This wouldn't have been possible had we not had broadband internet. Okay, so it doesn't matter today, where the website is hosted, whether it's hosted in Bangalore or is hosted in New York. It doesn't matter, or maybe Africa for that matter, right? As long as I have internet, good quality internet available. And then there is a commoditization of hardware and software. It means that we are not using very high end, you know computers developed by Dell or whoever, right? So this data center may use very simple computing devices built for their need in thousands. Okay, all right. And this slide gives, AWS is of course Amazon's uh, facility, uh, okay, or service. So the you here it simply shows that you can get, say small computing. They have created various specifications, right? And it says something which is small per hour rate is 0.021 dollar, is less than a cent. Okay, you can get it for 1 hour. So you can imagine, and then along with that, what are you're going to get here is two CPUs and some memory, GIB they call it, something like uh, 2 GB, I guess, memory, right? So it's very cheap. And you even, if you suppose you need 100 computers here of this type, then you have to just pay a few dollars. Okay, and there's a power, right? There's a power that you can. So this elasticity that you made. So today for 10 minutes you want 100 computers, and the next 2 hours you need 500 computers, and then 1,000 computers for few hours, and then again reduce. Okay, so this kind of demand, online demand, can be met by data centers. Okay, all right. So let's discuss in brief about this. Okay, so surely this is not the way to send your data to cloud. You know, all right. So data center in general refers to hardware software infrastructure consisting of thousands of network servers, which is nothing but compute, storage, and networking elements working together in synchrony. Okay, so in general, if you can view a data center is very large scale computer or license computer, that's what we call is WSC. This term is sometimes you will find in papers, not very heavily used. It's called the warehouse scale computers. You can imagine now, like we have imagined memory, you can imagine a computer that's very big providing you all this. And if you ask this question to possibly your parents or your friends, if they are not so technical, where all this data is coming from, they will say there must be very large size computer, right? That's all. So this very large size computer we can call is WSC. Okay, so and data center is actually infrastructure, and cloud generally we use word with services. Yeah, a cloud or cloud data services is a virtual version of data center, the way you imagine, and we always use cloud in terms of services. Okay, all right. So now we have almost like 1 lakh or 100,000 servers in data center. Most of the big data center that we have, like Google's or Facebook, each facility will have approximately 100,000 computers. And then they are connected to network, very tightly connected. When I say tightly connected, it means that, you know, the communication time has to be very small. All the networking algorithms you have used, routing algorithm, I'm not sure you have used those routing algorithms, right? BGP, etc. It's not applicable here. Okay. Here the hierarchy is very well known, the way the computers are connected. See, look at the internet in general, right? The way even LAN is connected, or multiple LANs are connected, or the way there, can you say there is some topology or some, graph topology exist in connection in IIT Goa? You cannot say that, because internet allows anybody to get connected. So internet does not follow any great technology topology. Now, okay, while within a data center, okay, there is everything is under the control of data center management, right? So first thing is that all computers are of the same type. Okay, so there's a great homogeneity, and then you can create the topology inside. Who stops you from creating, say, a topology like this or a tree? And in fact, we use something called fat tree. There are more links here and less link there, and at top and so on. So there is something called fat tree that is used, and all. Then you communication, no one may want IP communication to happen there. There can be any kind of communication happening inside, right? As long as it's very efficient. Okay, so it means that data center is always in a controlled environment where everything is controlled. Okay, all right. Uh, so there is also a great emphasis on cost efficiency, which we have seen. Otherwise, services will not be they will not be able to provide online on demand services. Okay, there's a we'll come to this. Cost of power is usually quite high. Okay, and we have seen that homogeneous hardware and software. This point also we have seen, we can see this as a very large size machine. Large size application can be hosted. Okay, and important is that highly available, less than 1 hour downtime per year. This is also very high limit. If Gmail is down for 1 hour in a year, then considered to be very bad. Okay, all right. So today's data center, they are very specialized data center built around big applications. Say for example, Google's data center will be very specialized towards supporting Google applications, say Gmail application. Okay, so we can have very specialized data center, or we can have a cloud data center, right, which is for general public, like EC2, Amazon's EC2, a Windows Azure, or Google App Engine. See, these are the made where facilities is shared across multiple users. Okay, now let's come to let's see how data center look like, right? This is inside view of a data center. This is from top, or top view of data center. This is Google's data center from side view. This Facebook data center from the side view. This is Google's data center in Oregon. This is a huge amount of facility. Usually you can see there must be at least three big data centers here. You can see something for cooling here. Yeah, maybe these two are the data center, this office building. Okay, all right. Yeah, that's interesting. That's not boring up here in a cloud. You get to look through everyone's data. The size is quite big of a data center. Okay, because it should be able to host close to 100,000 processors. Okay, so inside, this is an inside view. You can see there are racks. This is called a rack. Okay, and this whole thing is called array. And inside each rack we have a computer. So this is, there are slots, right? Usually 48 or 80 slot or something like this. And size is also nowadays, everything is fixed, right? So if whatever company you go and see their local data center, you will see that even everything of the computer is well defined, because it's like a tray that goes inside, and it has to be of some size, like 1U or 2U or something like that. I remember buying this for the company I started. Okay, so this is one computer. We'll look at this, right? So this is kind of on top, the wiring goes on, see, on top of each rack. Okay, each rack there will be some cables, right? Because their first thing is networking inside, and there is usually a switch on top. It's called top of rack switch, and then this top of rack switch in turn are connected, right? So this kind of cabling that happens here, you can see these are the cables. Okay, this is one view, how it actually a very badly managed data center might look like this. And this is one rack. This is one kind of large size storage, which is totally air cooled, and inside view is this. It's called container. Okay, now it can be container based or non-container based. What we have seen earlier is kind of non-container. These are non-container. This is not really a container. Possibly, you put this in a large size container, you can also call it container based. All right. So what goes inside a data center? Servers are organized in racks. Okay, these are all racks here, we can see. Okay, and these are homogeneous. All server processor of the same type. Okay, and each rack has top of the rack switch, because all these computers in a rack needs to be connected. Okay, so there is a cable that runs to connect all of. So each of these server or computer is connected to the switch. Okay, on top. So you can see that each server there's some wire goes on for each server. Okay, all right. And this is a view where each of these server, which is like this is shown here, is connected to top of rack switch. This is switch. This is a switch, means that is a router kind, right? Is usually it will be Ethernet switch and some routing capability. Okay, and then they in turn is connected to a centralized switch or aggregate switch, which is shown here. Okay, all right. So this is another view. This is a rack, and then these racks are in turn put into a particular shape. Okay, which we call as a cluster. A rack is an element of cluster, and within each rack we have this kind of a server or computer. Okay, it will go inside here. So you can see inside view of a rack. So these are each servers. You can see these are 48 or some number of servers, right? Okay, and then these are the racks. They are in the form of cluster, and we can sometimes we call it a row also. Okay, now here we see that in this cluster or in this rack, the switch is in the middle. So there are some clusters, some racks where switches are in the middle, but it will be uniform, right? And then it's connected to, and so it means that this switch is in the middle, and these switches are in turn connected to a cluster switch here. Okay, all right. Any question? Is it becoming clear? Okay. Okay, who can tell me? Ankur? Ankur, you are listening? Okay. क्या हो गया भैया? Okay, Anmol?
Yes, sir, I'm present.
Huh. Okay. Are you able to understand?
Yes, sir.
Hmm? All right. So here is a view of a rack. Okay, this is a rack, and this is array or cluster. Okay. All right, and inside rack, something like this will go. Is a simple one, server, or we can say a computer. All right. So this is inside view of this server is something like this. This is what Google does, right? So it's a very primitive. Normally they don't have terminals, they don't have keyboards. Okay, they have very minimal hardware infrastructure. Okay, all right. All right, and then we'll see the racks and clusters, and then cooling becomes very important because they generate enormous amount of heat, right? So the cooling is properly managed, designed, architected, and so on. All right. Now let's look at the monthly cost amortized. Amortized means that at the end of year, you see how much you spent on each activity, right? So you can see that maximum cost, monthly cost is on servers, which is almost like 57% cost. And then power distribution and cooling equipment and power equipment. All these 2 points are related to power. So that is the second important component. Cost of power equipment and cost of cooling because of heat dominate is second largest cost factor. All right. Of course, this does not take human costs and other costs, right? But so it's very important to because data center absorb or data centers use enormous amount of energy, and there is a lot of focus to make this data center highly energy efficient. And you can see announcements by Amazon and Google, and they say our data centers are green. Okay, they consume very less power, or if the power is consumed is a non-carbon power actually, through they either they have their own generation of power, say solar power or some other power, right? And then greening does not mean the greening like this. Okay, this is simplest way of the greening it. All right, so let's look at the requirement of a data center. We need parallelism. If data center does not provide parallelism, is useless. We need high availability and fault tolerance. Okay, it means that it must handle failures gracefully. If a computer is down, does not mean your task, user's task will be impacted. Okay, now largely is because of virtual VMs, right? Not virtual memory, but virtual machines. Okay, so basically we have VMs, and then in case of failure, you just move VM to other server. Okay, dynamic management, workload management. If there is a one data center is heavily loaded, then move work to different data center. Okay, so your query may go to first query may go to one data center, second query may go to second data center, and within a data center also there is a need for load balancing. Okay, not only location but within the data center also. And there's important point is multi-tenancy. Multi-tenancy, it means that multiple tenants or users should exist, right, or share these resources. So I may get illusion that my machines are separate from some other users machine. There is a possibility, and it usually happens that my VM, because I will ask certain number of VMs, are hosted on the same hardware. So my VM and your VM may be sharing the same hardware resource. Okay, and that's possible. That actually happens. Only then data center is efficient. And then it means that once sharing is there, and users don't like sharing, it means user may demand security and resource isolation. Okay, and since my resources are shared, I may also want from service provider or data center provider some kind of service level agreements that I need this kind of services in terms of performance and reliability. Okay, so to just last few points, cloud is distinguished by shared platform, and it gives illusion of isolation. This point we have seen. So if there are multiple users, they may then data centers to provide facilities for that of isolation, security, etc., and fair allocation of resources. Okay, and attraction here is low cost cycles because of economy of scale, right? Because we are buying things in 10,000 or 100,000, and then all these things are specially designed for data center. And so a lot of optimization here in terms of cost. And because of that, per cycle cost, CPU cycle cost is very low. Okay, right? It's like, your Uber may buy 10,000 cars, then of course they are going to get significant discount, and they may in turn say that I want cars, we shouldn't have all fancy features, because fancy features are not required in a cab, right? And elastic service from user perspective, pay what you need, pay for what you need, etc., right? Now let's look at the data center bandwidth network requirement, because all these servers are connected in terms of using some network, right? And which we said is very well designed topology, okay, which we are not going to discuss now. But in general, this bisection bandwidth, it means that amount of bandwidth, because a simple query that you have, You search your name, it gets forked into thousands of queries, and thousands of documents are searched. So there is a forking activity, and then there is something called joining activity. All these results are combined together. Okay, so that will require, a simple query requires so much of network bandwidth. It means so much messages are going out and coming in. So this called bisection bandwidth. This, even one single query requires so much, so there are millions of queries happening. In the network bandwidth has to be very high. Unlike in LAN, right? For example, when you use LAN as a user, then you use it very infrequently. Okay, here the queries etc. will happen very frequently, right? So bandwidth requirement is very high. Low latency, it means that if you are using normal Ethernet etc., it's going to take so much time right, to communicate. Then the uh, that's not the luxury available in data center. It should take usually less than 10 microsecond for communication. So there's a, if you read some papers, then you'll find out that everything is kind of different inside the data center. Congestion has to be, you have to plan such that the congestion, because of congestion there is less, there is no packet blocking etc., right? Otherwise, if packet is lost in congestion or delayed, then it's of no use. No user will wait for few seconds for to get an answer from these. So there has to be effective handling of dynamic traffic. Burst tolerance is something that usually work comes in a burst. One query is there, then it will create say 1,000 searches inside, right? And then it's over, right? So you should be able to handle traffic in burst. Okay. All right. So all these things we have already seen. So what really data center network requires is traffic load balancing, support for VM migration. So I'm sure you understand the concept of virtual machines. So we have multiple virtual machines running on a server. Maybe this is for me, this is for maybe Pavitra, this could be for somebody else. And if this processor on which it's running that fails, then these VMs should be able to migrate to some other place. Okay, and let's assume a part of data center fails, then they should be able to run this VM onto some other data center. Or this is overloaded because some reason, even then these VMs can run on some different data center without user knowing about it, right? That's how data center should be designed. All right. Another 10 minutes or maybe 20 minutes. Okay, then we close. Okay, so this is one way you can see the data centers are organized, right? Okay, you can see that this is here. This is a view. This is a view of a single computer. Okay, and then we can see. Oh, I'm sorry. This is a view of a single server. Okay, this is one single server, and in that there are multiple processor, multi-core processes, right? And then we have L1 cache and common L2 cache and common DRAM. Okay, this is just one server, and then we have a rack switch. Okay, so multiple of these are connected to a rack switch, and then we can see this is this shows that there are multiple of these are connected here. Of course, the view is not given, but you can see the DRAMs, for example. DRAM is always corresponding to a server, right? Like this server. So there is a connection of so many servers having DRAMs and disks. Okay. Okay, and then these rack switches in turn are connected to a central switch or data center switch, and thousands of these are connected in turn, like shown here. Okay, so we can see that for single server like this here, the DRAM is 16 GB. Okay, and then access time is 100 nanosecond. Okay, and then the bandwidth is this one, 20 GB per second. Now 20 gigabyte per second is bandwidth. Okay, bandwidth is amount of transfer that can take place. Number of 20 gigabytes are transferred per second. Okay, similarly disk capacity is given here. Now when we look at this data at rack level, just a minute, let me clean this up. Rack level, then we can see that overall capacity, DRAM capacity is 1 terabyte, while for single server is this much. We can see that access time has gone up to 300 nanosecond, and then however bandwidth is increased because overall memory is more. Similarly, multiplied this with 80 servers, so you'll get 160 terabyte disk available. Access time in general is increased. Now when we say access time is increased, what does it mean? It means that if a server here is trying to access memory of some other server, because all this memory we cannot say can be used only by that server. Okay, so resources are totally shareable in data center. It means that the cache of one server can be used by cache as a cache for other server, or RAM, main memory for a server, can be used by main memory and second server, and all this optimization has to happen. Okay, similarly at rack level, because there are 30 racks, we can see overall capacity is gone up. Okay, and while access time is also gone up, because this is what is given is kind of average access time for some load. So what we can see is that there is a lower latency of DRAM in another server than local disk. So it means, what it means is that even a server is trying to access DRAM or main memory of some other server, even then access time is lower than if it is accessing its own disk, local disk, right? And so on. All right. So it's all shown here. And we can see that within a data center, load varies continuously. Okay, and during the noon time, the load is maximum and the load is minimum in the night. Now remember, this data center, if is used locally for a city, then or country, then this curve is valid. Okay, if the data center is being used for all over the world, then there is a midnight or noon at any point in time across the globe, right? Whatever is noon time in India, maybe midnight in US. Okay, and so on, right? So it means that now data center should be able to cope up with this kind of load, because it surely sometime or other there might be congestion, but overall when there is a low period in USA, this may be a peak period in India. Okay, so that's how data centers cope with workload variation. Of course, there is a correlation to power consumed and server utilization. Will not go into it. We can see power cost is significant part of overall cost that we have seen earlier. Okay, last few slides. Okay, in general, you will come across this terminology called SaaS, PaaS, PaaS, or IaaS. So just want to clarify on that. Okay. Okay. So when we say SaaS, it's nothing but software as a service. Okay. So what does it mean? Say for example, there is a software service. Say for example, some accounting software. I don't remember now even the one which I've used. Say for example, some accounting software. Let's assume, what is that for a corporate? Anybody remember any accounting software name? Well, I mean, let's assume that some accounting software.
Tally 9.
No, that's a very that doesn't run. That's only for PC. Okay, there is a company, right? just within half-kilometer from home here. I just forgot the name. Anyway, so let's assume there is some software, accounting software. Okay, and the huge size software designed by say for example is designed by Oracle, or we can say yeah, Oracle as a accounting software, for example, they developed it. Okay, then I don't want to own that. I don't want to buy it, right? So let it be there, and then it's provided to me by say Amazon. It's already hosted on Amazon, so I may create my account there and use that application whenever I want. Okay, so basically I am instead of buying that the whole thing, I am just using service, that software, online whenever I want. Okay, so one example could be Google Docs. Okay, Google Docs is a service available to me. Okay, and this application runs there on Datacenter, Google Datacenter, right? But I am not buying that. I'm using it whenever I want. Okay, all right. So basically, this delivers as software as a service, delivers application over internet, eliminates need to install, run on customers' computers, and simplifying maintenance and support. Okay, all right. So we have so so look at this is cloud computing stack. So we have infrastructure, platform, and on the platform, say platform could be what OS and what other things are there, right? And then on top, this service is running to me for me. So when I hired this, then this is available to me. Directly service available to me. I am not bothered about where it's hosted, what in platform it's running, whether it's a Linux or Windows or whatever. I don't care, as long as the interface provided to me and how that is APIs, whatever, I am able to use this service. All right. Second is platform as a service. Okay, so it delivers computing stack as a service using cloud infrastructure to implement application. So I may say want, for example, environment which is a Windows environment, Windows platform, fit some tools. Okay, then I can take this environment on rent and develop my software or application on top of that. Okay, so it means that I am just buying kind of platform. Okay, say for example, I can buy Hadoop on EC2. EC2 is kind of data center services provided by Amazon. Okay, and I can buy Hadoop environment or platform. On that I can run my own applications. Okay, and third is that, for example, for my company's need, I don't want to buy even a single computer. Okay, I will say that give me servers and software and data, it will be hosted of course in data center. So instead of buying servers and then loading your own application software or use it for computing as a computing resource or software development, you just buy that infrastructure from, or you rent this infrastructure from a service provider. And this we call it IaaS, the infrastructure as a service. Okay, so we see that infrastructure, you ask for computing, you may for example ask number of virtual machines, capacity of virtual machines, how much memory you need, okay, storage you need, how much, what kind of networking facility it has, right? So it's same as creating your infrastructure. You hire it from say Amazon or some other service provider. Then you do, all you need is high speed network to connect to that. Okay, so we have seen that infrastructure as service. Then we really don't want to even bother about infrastructure, and we say that provide us Linux or Unix or Windows environment with certain facility. Then we will say that give us platform. Of course, there is an infrastructure built into it, but we are not hiring that. We are taking platform here. And third level is we just even don't worry about platform. I don't care where you host. All I want is that my application should run and give me that application. All right. So these are the three things. Something on top is SaaS, then platform, and then IaaS. All right. These things are very simple. All right. So I will not go into it. This again, same thing as the cost, right? That we have seen earlier, cost diagram, what is the cost per unit price, etc. is something like this. Okay. To summarize, cloud and data center. Okay. How do I summarize using this? Okay. All right. Today, the world is very different what it was few years back, and in future also it will be very different. Lot of communication is happening. Okay, the lot of computing is happening at different places for, and number of devices, as we have seen, is also growing. And we have, and not only human to machine communication happening, uh, we are able to use whatever devices we have and run massively parallel application somewhere else. So from my mobile, I can run massively parallel application in anywhere in the world in data centers, whatever place the data center is. Okay, and of course, number of devices are also growing in a, with a, as we have seen, IoT is happening and more machine to machine communication is happening, and then this provides us, the cloud and data center provides a virtual world. We can treat this all as a cloud, and what understanding we have with the cloud, I will request for my service and that service should be provided to me, and that service could be as we have seen, it could be infrastructure or it could be a platform or it can be application or software. Or application, right? And the advantage is that I can get what I want on demand, and I need to pay only for that. Okay. Advantage for cloud service provider is that they are able to be massively large data center or cloud at very low cost because they are buying in thousands. Okay, and because of this massive scale, everything is low, maintenance is low, cost is low, electricity consumption is low, and they are able to share the bandwidth or computing resources or computing bandwidth, storage, etc. across number of users in very effective and efficient way, such that each user feels that the whole data center or an enormous amount of capacity or capability is available for him or her alone. Okay, all right. I think that's all. Any question? Okay.
Sir, any disadvantages?
Oh, okay. Very good question. I like it. What could be disadvantage? You tell me. I don't see. It's like this, that okay. So disadvantage for individual user is that if is not able to use whatever he has hired efficiently. Could be one disadvantage for individual user. At overall, see, it's something like this. This whole model works provided the utilization is over 50%. Actually, most of data centers are not utilized more than 50%. Okay, even then they are profitable. All right. So one disadvantage is for service provider could be underutilization the whole data center, so they are non-profitable. In fact, most of data center in the beginning remains non-profitable and profit comes only after some time. There's a one disadvantage I could think. What else actually? You are good question. I never thought
So,
of this disadvantage.
so can someone use it as a like malware as a service maybe and spread it like a broad botnet network or something?
Possibly yes, if a data center, if it's not, if it's kind of not visible to data center people or cloud service provider, they may see. Obviously, everything that we do, there is always a contract, right? For what I'm using, right? If the contract allows it to be used as a malware as a service, and is a growing thing, right? There can be, see, how do you know that all data centers and cloud provider are going to be ethical companies? One can always in dark part of the cloud, dark cloud, right? So you would have heard this term, dark cloud. There can be service provider which will rent, servers to do DDoS attacks, denial distributed denial distributed denial service of attack, right? There's a possibility. Don't know really. I mean, it totally depends. If North Korea, for example, can create such a data center to disrupt the world. So it totally depends on individual company for what. See, it's like this. There is a huge amount of computing and communication power available. What do you use for depends totally on you, right? Totally depends on company that's offering you the service, right? Malware as a service is a growing field. Okay, so you can actually, you don't need to write viruses. You can rent viruses if you want to infect your enemy's laptop or desktop. It's all available. Okay, any other question? Okay, all right. So that's all about the course. I hope you learned something. I tried to teach whatever I know. Okay, and now about the exam. So I plan to take it after 20th. So you tell me the date, and I think I have to give final result by 25th or something. I don't know exactly. I have not seen emails from office. So please let me know the date you want me to take the exam. It will be of about 1 to 1.5 hours. Pattern would be exactly same. Platform will also be the same. Okay. Okay, this time I will not allow you to know the answers. Reason is that I may use some questions maybe next year. So don't try to copy it. Okay, you will not be allowed this time to scroll back. Uh, so you have to just, I will tell you the structure of the paper, how many questions you'll have. So accordingly, based on numbers that question has, you can allocate time for it. So, but you will not be able to scroll back because there have been some cases, at least I came to know from system that some people have communicated result among each other. Okay, so I don't want that. Because I mean, here honesty is very important. I mean, you're doing exam from home. I assume that all of you are extremely honest. Okay, but at the same time, I need to be careful. Okay, all right. So who will tell me the date and time of the exam?
Sir, I have already asked on the class group. I'll let you know as soon as there's a majority
Okay, just send me
opinion.
an email. Okay.
Yes, sir.
If I will try to put all the lectures, whatever I have recorded onto system in 1 or 2 days. Okay, 2-3 days. I mean, each requires about 3-4 hours of editing because the editing software that I have just takes a lot of time. It's commercial software that I bought, but it takes a lot of time. So I have to, each presentation. If I put as it is, then it is just 10 minutes job. But I don't want to do that because in public forum, need to clean it up. Sometimes I don't clean it up, but mostly I have to clean it up. It means that I have to go through the whole lecture all over again. And all right, so that's all. Any question?
Sir, about syllabus, it will be full syllabus or it will be after mid-sem?
Okay, it's like this. I want to take multiple tests, but things were going so slow in the course. Okay, I couldn't take many tests. Also because of COVID, it's not easy to take multiple tests in COVID times, right? So I have just 2 exams, and based on that, I have to assess you guys, right? Okay, so I want to answer your question. Yes, majority of the questions will be from the part that was not covered in the last exam, but there will be questions from part that we have covered in the first exam. Okay, this because this is a final end term exam. Because since you have already studied, you just need to revise it. As simple as that, right? You don't need to go too much into detail about it because you have already covered it.
Okay, sir.
Okay, all right. Any other question? Please, in case you are stuck somewhere, need any help, please feel free to reach me. I am always available. Okay, so we don't have a class on Monday. So this consider this a last class. If you have any doubts or you want me to take a class, I am happy to take a class about the doubt that you may have. All right. Okay. Thank you very much.
Thank you, sir.
Thank you.
Thank you,
Bye.
sir.
Bye. Bye.
Thank you, sir.